A set of 3 computer programs has been prepared to extend themes covered in Scientific Eye. These are available as discs for BBC Model B and BBC Master computers. Please send cheque or postal order for £29.40. This includes VAT and post and packing, made payable to the Educational Television Company, PO Box 100, Warwick, CV34 9TZ, or contact your local ITV company.
This is gold, a rare and valuable metal. But other metals only become valuable when they're put to good use. What properties do you look for in a metal? Which properties make metals useful? A 2p piece will make an impression on a soft metal. Aluminium and zinc seem much harder than copper and lead. But was the test fair? So lead is soft and it also bends very easily.
Lead gone 100 grams.
Copper and steel are much harder to bend. Does this mean they will spring back into shape?
Number 2's gone. Number 3's gone.
Which metals make good springs? And how would you test for springiness? First, you need to make some springs. This one's made of steel. And this is a lead spring. What measurements would you make? So how much use is a lead spring? For any job, there's usually a range of metals that can be used. What sorts of metals do jewellery makers use? He's making a bracelet out of silver because it's got the right properties. Copper can be cut with a pair of scissors. What sort of metal do you need to cut the grooves in a silver rod? Jewellery makers spend most of their time changing the shapes of pieces of metal. So the metals they use have to have the right properties. They must be easy to cut, easy to bend, and easy to melt. And above all else, they have to be attractive to look at. And some metals are attractive to listen to. Which metals make sweet music? Slot machines need to know about metals. They're fed metal coins, and they have to sort out the good coins from the fakes. And check how much money's been put in. But how can you detect hidden metals? This is an emergency unit. The patient has been shot, and they're looking for the bullet.
It entered laterally here.
Here it is, stuck in his kneecap.
Bone here.
Yes.
And probably lodging in it, as you can see here.
A compass will help you find some metals. Copper and zinc aren't magnetic. Nickel is. And so is steel. So could a compass help you search for hidden treasure? Under this green paper are metal objects which they're trying to detect.
Some of them.
Why do you think they missed the scissors?
We missed one there. This one there.
Real treasure hunters use a more sensitive metal detector that doesn't rely on magnetism. This one can detect anything that's made of metal. This time, it's only 50p. But supposing you dug up an old bracelet, how would you find out which metal it was made from? One simple way is by measuring the density.
We found out the density by weighing them in the air and then weighing them in the water. And we found out the difference, which is the same as the volume. And then we divided the weight by the volume, which gave us the density.
This bracelet's made of copper. But is this ring made of gold?
Gold ring.
First, weigh it in air.
5.97.
5.97.
It weighs near enough 6 grams. Now weigh it in water. The difference in weight is 0.4 of a gram, and this means the volume of the ring is 0.4 of a cubic centimetre. So is the ring made from pure gold? This is Saxon jewellery, 1,000 years old. It was dug up in a field in Norfolk. How would you find out which metals the bracelets were made from? hoard of old coins hardly looks like metal at all. That's because metals corrode. They react chemically with air and water. Heat this sheet of copper and it reacts with the air. You can see the reactions happening because all these colours are thin layers of copper oxide. Hot metal can burn if it's in small enough pieces. This piece of brass needs protection. Jewellery makers normally work with soft metals, but brass is hard, so he'll have to change its shape by using chemistry. He scratches a pattern through the layer of black wax. This doesn't affect the metal at all, until he drops it in a bath of acid. The acid has eaten into the brass and etched the pattern. You need strong acid for brass, but there are weak acids all around us. Lemon juice is a weak acid and it reacts with some metals. Copper is an unreactive metal. It doesn't appear to react at all with the lemon juice. What about magnesium? Stick two different metals into a lemon and what you get is an electric cell, a fruit battery with enough power to run a digital clock. Which combination of metals makes the best battery? That's what these scientists are trying to find out. They're starting by using two pieces of the same metal. With two pieces of copper, there's no voltage at all. What happens when they use two different metals? Using copper and an iron nail, the battery gives over half a volt. Now they're going to try copper and magnesium.
So which one's the most?
Remember, magnesium is much more reactive than copper. This combination produces 1.5 volts. So how does the combination of metals affect the voltage? And does it matter which fruit you choose?
1 point.
In this museum in Germany is an exhibit discovered in Baghdad, and it's 2,000 years old. There's a copper cylinder and an iron rod that fits inside it. Dr. Arne Eggebrecht has a theory about what they were used for and is putting it to the test. All he needs now is some weak acid. What will happen when the grape juice is poured into the cylinder? The Baghdad battery produces nearly half a volt. Could the ancient Persians have used the electricity to fool people with fakes? Why do you think the statue gets covered in gold? For thousands of years, people have been looking for gold. And if you know where to look, it's still there to be found. "7,000 years ago, the Chinese were making good use of gold and half a dozen other metals. They also knew about melting metals together to make alloys. The mixtures they chose depended on what they wanted to make. His recipe for perfect pots and pans uses 6 parts of copper and 1 part of tin. Which alloy makes a good arrowhead? Weapons of war are hard and sharp, so the bronze mixture needs less copper and more tin. It was a long time before they learned how to use iron. And another 5,000 years before a new metal came into common use. Aluminium is very light, but it's not very strong. So rock climbing equipment is made from aluminium alloys. Aluminium is stronger when you mix it with another metal to make an alloy. This is an aluminium alloy carabiner. Every batch is put to the test to make sure it's up to standard. The manufacturers want to make sure the carabiners are strong enough to support the weight of the climbers on the rock face.
You okay, Andy?
For a climber, the right mix of metals is a matter of life or death. This factory uses a wide variety of metal alloys. They're making mountain bikes. When you're riding a mountain bike, you need strength in the frame and reliable brakes. The gear teeth need to be tough. And what do you need from the spokes? Why do we need a variety of alloys? And why do different alloys have different properties?